So thanks for having put this paper on the program. So this is joint work with Patrick, Per, and Hannes, and it's our take on agriculture from a macroeconomics perspective. So the motivation of this project is based on two stylized facts that are well known in this literature and are often used as prima facie evidence that agriculture is key in order to explain aggregate income differences across countries. And so the first one is just that agriculture employment is a small fraction of the economy nowadays. Rich countries, so you have GDP per capita here on this axis, and in rich countries like the US, it's negligible. If you go to the poorest countries, it's well known that even a majority still of the labor force is in the sector. The second stylized fact is that labor productivity differences between rich and poor countries are particularly large in agriculture. So this is just plotted here. If you go to the Penn-World table and calculate for the different deciles GDP per worker in the aggregate income, then you see kind of, this is a well-known number, the differences between the first and 10th decile is roughly a factor of 35. So quite a big income differences in aggregate GDP per worker. Now, if you do a similar exercise and calculate a measure of real output per agricultural worker, if you do this for the agriculture sector, you see a gap of a factor of almost 100. So this is really staggering. So those two stylized facts put together are often used and referred to as suggesting that really agriculture is key. And of course, from an accounting perspective, this is always true. Now, when it comes to making policy recommendation and understanding what would change if we increase productivity in one sector of the economy, we of course need a macro model, and we need to understand what is behind this structural change picture. So why are those countries specializing in a sector where the labor productivity is so low, and also what is hiding behind those enormous labor productivity differences of almost a factor of 1.
Something that seems like up to the 10 to the 4%, the ratio is 2. It becomes bigger in the lowest deciles, right?
Yeah.
So it's not a uniform. It's not like, you know.
Yeah, that's right.
It's not like a factor of 3.
Of course, in particular for the poorest countries, it opens up.
Yes,
and
exactly.
It's going to be reflected in our results as well.
Okay.
So you're going to see that. But that's right. Yeah. But kind of, if I were to take the ratio between this number and this number, these numbers are always higher. Kind of, it opens up systematically. Yeah, up. Yeah, absolutely. Okay, so what are our goals in this project? So it's a macro take on this, and first we put together a data set and put data on the table about agriculture and non-agricultural production around the globe. For agriculture, we have in mind 4 production factors, which are capital, labor, land, and intermediate inputs. And we construct a data set about quantities and prices about those inputs around the globe. And then we just plot these data and organize it in terms of some stylized facts. Second, we then go step by step and introduce layer by layer of what I would call straightforward neoclassical theory to just see whether we can make sense of this data, to what extent straightforward neoclassical theory can explain the data. And then we can also back out TFP terms. We can build up a GE model and in the end entertain the counterfactuals in this framework, in this quantitative framework. This is all done with the goal to just make an overall assessment of how good does such straightforward macroeconomic models perform in order to explain it. Yep.
So this is true in the cross section. Is also true over time.
I'm going to talk about that. We're going to look at US time series data, and it's going to be striking how these things line up, but I will show you. Yeah. So what are our findings? So we're going to document some stylized facts. Some of them are already known, but it's kind of impressive, massive capital deepening and massive intermediate input intensification across countries. So if you look at the amount of fertilizer per hectare of land, how it differs across countries, enormous differences. Capital labor ratios in agricultural production, enormous differences. If we plot those stylized facts, those patterns are kind of really striking. They just jump at you and shout out kind of the neoclassical predictions, because what we systematically see is that across countries, some factor prices are lower. For instance, in poor countries, wages are relatively low to the rental rate of capital. And systematically you see in those countries where relative factor prices are low, they also use this factor more intensively. So in the case of agriculture, in the poorest countries, they use labor-intensive production. So it's kind of really those neoclassical predictions, at least qualitatively, really stand out. Strikingly, these relationships that we document are very stable across the whole income distribution, and are also strikingly consistent with US tax. We then put some structure on the framework and back out TFP terms. So we basically assume neoclassical aggregate production functions and interpret the data through the lens of such an aggregate production function. And we back out TFPs across countries. And what we see there is that actually a large chunk, 2/3 of this overall labor productivity differences between richest and poorest countries in agricultural labor productivity is endogenously explained through intermediate input intensification and capital detail. Okay, so 2/3, U.S. agriculture is, in terms of labor productivity, a factor of 100 more productive. 2/3 of this is explained because they just use more tractors per worker and they use more fertilizer. So what this gives us is that yes, there is still big difference remaining in TFP, but it's never as large as you might have thought by looking at labor.
But are you going to tell us why?
No, well, the TFP terms we're going to back out, and it's going to be endogenous.
No, but why do they use less fertilizers and less tractors, etc.?
Yes. So what we argue is that this is the optimal response, because they are, as a farmer in these kind of countries, you're going to be faced by different relative prices of factors, and because factors are relatively substitutable, it's optimal to respond this way. But the TFPs are of course backed out, and they are just
no, but you're going to show us like the price of tractors in Mexico versus the US, and
we're gonna show this later. Yeah.
This was Esteban's question. The question is whether is this like an amplification of some differences? Because I mean, at the beginning you said that somehow this is going to change the policy implications, but if it's about amplification, then maybe not. We ultimately is what those TFP differences are going to.
Oh, absolutely. No, you're right. And of course, we cannot go all the way, because in the end, there remains to be explained what is underlying these TFP differences. I think we can learn something from it, because one thing that comes out of our exercise is that, yes, the labor productivity differences in agriculture are enormously big, but this doesn't necessarily have to come from TFP differences in agriculture, because it's just a symptom that shows, but actually the underlying source is, according to our result, from a different sector, which is producing capital goods, producing fertilizer. Okay. Yeah.
So when you talk about this being, take the example of Mexico and the US, are you thinking about a neoclassical model of a closed economy, right? Because if you allow these two countries to trade, then what would happen is that the US should be specializing on agricultural goods, right?
We're going to go step by step. Until this point, actually, we don't have to make an assumption. We just back out TFPs. I'm going to show you. Later, you're right, we're going to close the model, and we have a full-blown dynamic GE model. There we're going to make, in the end, we're going to make the assumption that it's a closed economy. But
that's a big assumption.
Later. And maybe I can talk a bit about we have, of course, started thinking about extension where you open up for trade, and maybe I can talk a little bit more about those results. But yes. Yeah, but at this point, we don't actually make any assumption, okay? So, good. Yeah, another thing, and this is quite striking, is that there is a striking non-linearity in the TFPs. So basically, intermediate input intensification and capital deepening fully explains labor productivity in agriculture between middle-income countries like Mexico and US. Whereas there is still a sizable role to play, a significant role to play for TFP to explain the differences we see between the poorest and middle-income countries.
So, do you, when you say per worker, you already adjusted for human capital?
We're going to adjust for human capital the standard way. I'm going to show you. I'm going to talk a little bit about data because it's a part of our contribution.
So,
Yeah.
Timo,
Yeah.
just another, so once you account for these 2/3 differences in agriculture across countries, align with the aggregate difference in TFP across countries?
Sorry, say again.
So you said that agricultural differences in TFP are much larger than aggregate TFP across countries. So once you take into account or you measure these 2/3, the remaining third becomes comparable to aggregate differences in TFP across countries, even in agriculture, or still there is some
No, that's
dispersion?
right. I'm going to show you, but it's going to be comparable to what we see in terms of TFP differences between the poorest countries and the richest country in terms of non-agricultural. Okay, yeah. But yeah, okay. So we go one step further. We actually impose aggregate production function.
Sorry, just a small clarification. When you think capital deepening, is capital per worker or capital per unit of land?
Capital per worker is, yeah.
Because I guess one issue is smaller plot size. So, just getting more and more tractors on a very small unit of land will generate massive decrease in returns.
Yeah, so here we really going to take an aggregate perspective and just lump everything together and look at just averages across countries. But yeah, what I have in mind is capital labor ratio. Okay, we're going to go one step further. Just assume that there is one neoclassical production function that characterizes this data and just see how well this fits the data. Now, for non-agriculture, we find that actually Cobb-Douglas does quite well. However, for agriculture, we also see that aggregate production function is actually very well capturing the differences we see in this data. But it strongly suggests more substitutability between the factors, capital, labor, and intermediate inputs than Cobb-Douglas. We're going to go one step further, kind of just estimate and calibrate the demand side, like where we have to deal with non-homothetic preferences. We kind of calibrated to US time series data and show that it can capture a significant part of the demand structure differences across countries. And then we finally put this in G. We close the model with this demand side, with this production side, and calibrate it as discussed above. And finally have a quantitative framework where we can entertain counterfactuals. Yep.
So the first cross-country part where you do the facts, you had to you estimated the production functions to do that? Or?
Yes, we just fit it to the data, yes.
Right, but I'm just wondering if you could have used the time series, for instance, to restrict parameters and then use those to see what the cross-country.
I'm going to show you that the data nicely lines up with the US time series. So okay. in a way, it would give roughly, not exactly, but roughly a similar. So we take comfort out of this, of course, but this was really an eye-opener to us. Actually, we didn't plan to write this type of paper, but when we saw those pictures, they're really striking. And we decided to go for just a neoclassical story and see how far we get. Okay. Good. Yeah. And then when we entertain those counterfactuals, we can just check what happens. Suppose you now take a poor place and increase TFP in agriculture of this poor place to the TFP level that we see in the US. How much does GDP per capita at the aggregate level increase for this country? And the takeaway message here is that yes, from a Houghton's logic, locally, they employ a lot of people there. There's a big sector in the poorest places. So if you boost TFP there, you get initially a sizable increase in aggregate TFP, aggregate GDP. But this effect is, the model is very non-log linear because this induces structural change out of agriculture. So the boost that you get decreases. And actually, if you increase TFP to the level of the US in the poorest country, this country can never become a rich country. So the effect, the aggregate effect, is actually petering out very rapidly over the development process. And this is not a recipe to develop through the lens of our level. Yeah. Whereas the opposite happens if you increase non-agricultural TFP, because then it allows you to use intermediate input intensification, capital deepening, and actually also solve the low labor productivity problem in the agricultural sector.
That's where trade. Or that's where trade is key.
Yes, absolutely.
Those things, then
If you have something to offer on the international market, where you're also productive, something to trade, then you could do it as well. Good. Yeah, and maybe I'm not going to have time to talk about the land exercise. So let's talk about the data briefly. So what we want to capture is data on inputs of labor, capital, land, and intermediates in agriculture and non-agriculture as well. And the guiding principle is that we want to make it consistent, our data set in the end consistent with the aggregate data as well. So with basically with the Penrose data. And it's going to be hard, so we have to make some compromises, but here is what we do. So we have kind of nominal capital stock in agriculture from FAO. We can back out the average return on capital just from the Penrose table, which is very flat across countries. And then the tricky part is to come up with a measure of the real capital stock. So what we do is we assume that the capital deflator in the Penrose table is the same one that we use for the capital stock in agriculture. Okay, so that's an assumption. For labor, we do back out wages per efficiency unit, the standard way. So we consistent with the Penrose table. So human capital adjustment we do the standard way by using data on mean serial returns and data on schooling. And finally, this gives us data on wages. And in the data, we also observe bodies and not efficiency units. So there we adjust and just assume that the human capital level of somebody working in agriculture is half as much as in the rest of the economy. So this is based on some nominal wage differences across sectors, plus some expert judgment, I would say as well. Okay. So when it comes to land, we basically rely on Adamopoulos and Ristuccia to adjust for quality of different plots of land. So it's not just we have a size measure, but we have a quality adjusted size measure for the quantity. Then we target directly the land share. For the rich countries, we have good data for the rental rate of hectares of land, and we can directly calculate the share. For the poorest country, this is a tricky issue, and what we in the end up doing is you go to the micro data where we observe some farmers renting plots of land and use that to match the share in sales that those farmers have. Finally, intermediates. So intermediates, it's important to emphasize what we mean by intermediates are intermediates that are used in agricultural production, but are coming from non-agriculture. So this is mainly fertilizer, seeds, pesticides, but not manure, because manure is coming from agriculture itself. So we net that out using input-output tables by just focusing really on the part that is coming from non-agriculture and is used in agriculture. So from the input-output tables and national accounts, we then directly have the shares. But what remains to be constructed are the prices. That was another challenge because the last price survey the FAO was running was from the 90s, and basically all the poorest countries are missing. So what we end up doing actually is we go to the unit price data that we see at the custom from the trade data, because this stuff is also traded fertilizer, and you see there the kilogram price in US dollar at the custom, and use that to construct the price index for fertilizer and intermediate inputs. We also look at pesticides. And the remaining quantities and prices, which is the land price and the quantities of intermediate inputs, we just back out by those identities. So here is the data, okay? So we have 4 input factors. This gives us 6 bilateral pairs, and we just plot them here in one slide. We have on all the x-axis, we have GDP per capita of the different countries. And then we plot in one particular panel, we plot relative quantities and relative prices of 2 factors. So here it will be capital and labor. And what you see is systematically, of course, capital is the dashed line is relative prices reported on this axis. We see that capital is relatively expensive compared to labor in the poorest countries, and it becomes cheaper when you move to the richer countries. The data cloud is not plotted for the prices. And what you see is that if you look at the capital labor ratio in agricultural production, it's much more capital intense in rich countries. So that's maybe not so surprising, but kind of enormous differences. Okay, so these scales are all logarithmic, and the differences are just enormous. The other striking pattern is really how stable those relationships are in all the figures. Okay, how more or less log linear they look. And the other thing is that the neoclassical predictions are really borne out in this data. Yeah.
So the price of capital comes from where again?
The measure of capital.
The price of capital.
We just assume that the price deflator from the Penrose table for the aggregate capital stock in the particular economy is the same as the deflator for the capital stock in agriculture in this economy. No.
The price of capital.
But that's okay. That's how we construct a measure of real capital, and then we use the return on capital to back out the user cost.
We assume that's the same across every country.
No, we estimated.
The rate of return.
No, that's also estimated in the aggregate Penrose table data.
But I thought that didn't have it was just one number, R.
No.
No, it's on index. It's on index.
It's estimated.
Oh, I see,
this
but
way.
it's country by country.
It's country by country,
Okay,
just
okay.
from the
I
Penrose
thought it
table,
was just-
because
okay, I get it. Sorry.
So you can use capital, like the price of tractors, like importing capital goods as well. I mean,
We could- we could do that. That's right. Yeah, we could do that as well. And it actually won't change the overall message, because what is also behind this data is basically, you can roughly think of the US dollar price of a tractor being flat across countries, the US dollar price of fertilizer being roughly flat across countries, but of course wages just going dramatically down. That's roughly up to a first order, what you see in the data. So that I think would give you a similar result.
And the difference in wages are kind of
Exactly. Yeah. It just wants. Okay, so just to bring home this point, very stable across the full income distribution. And the other thing is really the neoclassical predictions are borne out. Whenever the relative price slopes down, the relative quantity slopes up. And also what you see is that in the cases where they slope less steep, also the quantities slope less steep, okay? Which is kind of. Next, we go to the US time series and basically do the same exercise and plot in the same figure, just the US time series for the post-war data, and report the US at what particular level of GDP per capita they had back in time. And do that for all those relative quantities in agricultural production. This is what you get. So it's kind of striking how those patterns, those relative quantities really line up, the slopes really line up with what you see across countries. So also over the course of time of development in US agriculture, it was a massive capital deepening, massive intermediate input intensification. And if you line them up with the particular level of development, it lines up nicely with the cross country.
Except for the capital.
The price is a little bit, yeah, that's right. But the quantities are. Yeah. You mean this one?
Yeah.
Yeah. Well, it's covered by the picture. Yeah. That's right. Yeah. The rate of price is not lining up.
Well, you know the bottom.
The quantities too, right? it's remarkable. Exactly. That's right. So the other thing, how we can plot this, we have now quantities and prices. We can also just plot cost shares, right? Because they give us.
I guess it would be interesting to see, because the first two pictures, you can do it also for non-agriculture, and qualitatively would have the same shape.
Yes. Qualitatively, there we take the view that there are just two factors, capital and labor, and it takes the same qualitative, the same shape, but it's less deep. Okay, that's why it's. Yeah. I mean, yes, we basically have it, but I don't have it in the slides. But basically, that's also underlying our conclusion later that the Cobb-Douglas actually does the job for non-agriculture, whereas for agriculture you need more substitutability. Good. So we have quantities and prices. We can also back out cost shares, and that's kind of what we plot here. And the kind of the main takeaway here is that the cost shares are non-constant across countries. So here is shares in gross output. You see kind of enormous intermediate input intensification. So the share of intermediates is growing a lot. It's kind of very big in rich countries and negligible in poor. And here we just focus on value added, and within value added you see capital deepening. So the green area is really growing. Very little capital in the poorest places, and significant capital in the rich countries. Whereas, and that's also interesting, the land share actually is remarkably constant in terms of value added. Good. Then let us make another step. And now we basically assume additionally that one neoclassical constant return to scale production function characterizes these data and back out TFPs. So we assume that agriculture output is given by a TFP terms times a production function defined over capital, labor, intermediate inputs, and land. For non-agriculture, we do the same. Just assume it's based on two factors, capital and labor. We make one additional assumption. Again, we're going to have a 4-sector model where we also have intermediate inputs and capital. There we make the simplifying assumption that the isoquants are the same here for all the non-agricultural industries. That makes our life a little bit simpler because we can directly read off those AX and AK terms from relative prices we observe. That's all.
Timo.
Yep.
So the cross-country differences in agriculture that you showed us at the beginning are based on a value-added measure of TFP, or these gross output measure that you have there in question 1?
That's based in gross output, yeah. This is a gross output.
Yeah, but
production.
the numbers you were talking about at the beginning, those were gross output
Absolutely.
differences.
Yep.
Okay.
That's right. Yeah. What we then do is we do sort of Solov style exercise. However, we do it in GDP per capita space as opposed to time. So basically we project all the measures that we had, inputs, cost shares, and output on a measure of development, which is GDP per capita or per worker, we call Y. And then we just define a change in TFP. Let's just focus on the non-agriculture sector because it's a bit simpler. The change in TFP between two countries in GDP per capita space as the change in output, real output of non-agricultural output, that is unexplained or unaccounted for by the cost share weighted change in physical capital and change in human capital. The same thing as Solov did in the time series. Here we just do it in a different space, which is Y, and Y is GDP per capita. But it's the underlying assumption is just that there is an aggregate production function characterized, but it could be anything.
So the cost share,
it's basically these are the cost shares.
Okay, you observe them in the data.
Because we have quantities and prices, we can also construct cost shares.
Cost shares.
Yeah.
Okay.
But shares are fixed in your growth account, or
No, they're just what they are. Of course, they vary in Y, which is GDP per capita, as you can see it here. Yeah, that's what we feed it. It's like you do growth accounting and they might vary over time, and you just put it. Okay, and this is kind of what we get. So we normalize everything to 1 in the richest country, and then we just plot the 4 TFP terms. We see kind of the biggest difference actually we back out for intermediate inputs in terms of TFP. Then the second is kind of investment goods, and then non-agricultural consumption goods, the green one. This is kind of well known that TFP, or because relative prices are sloping more. Poor countries are particularly bad at producing investment goods, and this is well known. And the kind of of course, the main thing is the red one, which is agricultural. And here you see kind of strikingly non-linear shape. So if you go to a middle-income country, actually there is no TFP difference in agriculture, even though there are big differences in labor productivity in agriculture. Overall, it is roughly the same if you go to the poorest country as for investment goods in terms of TFP gaps. But if you compare it to what I'm motivated to talk with, the labor productivity. So the red one is the labor productivity difference, which is this factor of 100. All the way up to here is endogenously explained through capital deepening and intermediate input intensification. So 2/3 of this gap is fully explained by those endogenous forces. And it's just a symptom that is actually coming from a different sector, low TFP in a different sector through this. And this is kind of the residual gap that is swallowed by TFP in agriculture. Good. Then we actually put the functional form, and we use different nested CS production functions. We basically write down the first order condition and then estimate from the first order condition those sigmas, which are the controlling the elasticity of substitution, the weights. And what you see there is that a simple nested CS like this one over the 4 inputs does a fantastic job in matching the cross-country data weights. This is kind of the fit that you tend to get from such a global production function specification. And you see you miss maybe a little bit here and on the bottom, but overall this is kind of does a fantastic job.
So you go back to so it's like capital, and the first thing is capital
and labor.
H is hours worked, okay. L is land.
L is land, and this is intermediate. So this is actually the baseline that we choose in the end. We're going to show you a different. We of course tried out different nests because it's non-trivial how you nest the different things. We actually use this one because that gives you the elasticity of substitution directly pinned down by sigma 1 between capital and labor. This is something that people have estimated, like in the US time series, with a different approach, by the way. And it's kind of in line with what we find with this kind of fit. So you tend to conclude that the elasticity of substitution needs to be systematically larger than 1 for agricultural production.
And that's just an OLS estimate from
that's
the first.
OLS estimate.
Yeah,
Exactly.
you're not worried about any endogeneity.
I wouldn't claim identification from this. We just fit something and see how well it does in terms of fitting.
No, but it does matter for the estimate of sigma. It does matter for the estimate of sigma, of course.
You mean you would come up with an instrument, or what do you?
Yeah, I mean, obviously your estimate of sigma could be biased, right, by my specification.
No,
so that's
I'm not claiming any identification. Right. All I do is just write down this production function. Let's see how it fits this data that yeah. Good. For the other elasticity with an SCS, it's a little bit non-trivial because they are non-constant, of course. So what we then do is we try out different nests and just compare what we get in terms of Moroshima elasticity of substitution for pairwise factor pairs. And kind of the striking pattern that we find is that no matter how you nest things, those elasticities are kind of disciplined by this exercise quite tightly. They're very stable across countries. So this one, of course, is by construction, but these are not. The only place where the elasticities are not so tightly pinned down are with respect to land. There you kind of, these data can be matched with kind of quite a range of elasticity of substitution, which, yeah, you should maybe take into consideration. The other thing is, and this is maybe another just takeaway message from this exercise, is that these data that we put together strongly asks for some elasticity of substitution larger than 1. So of course, many people go with a Cobb-Douglas. To the extent that this data is sound, it strongly rejects a Cobb-Douglas because, yes, how can you make Cobb-Douglas consistent with change in factor shares? Well, you need to put in a wedge. You can back out what wedge this data implies. If you just show it for the labor compensation compared to the capital compensation, you see kind of it changes by a factor of 8 in the cross section of countries. So this suggests that you need to conclude that there is a 800% tax on capital in agriculture in the poorest country compared to us, which is of course unreasonable. If you do the same thing for the US time series, of course the US time series that we consider only goes up to here, but you would still conclude that back in the 60s in the US there must have been a 300% tax on capital in the agriculture sector, and nowadays it's 0. So it's unreasonable, I would say. Yep.
So one comment on this. I mean, the idea of taking these solo residuals, no, as an estimate of productivity, initially fixed these factor shares. You have, because you are thinking of the Cobb-Douglas, and then you use these fixed factor shares, and then you look at the variation in the use of quantities of factors, right, and then you get the residual, right, with these fixed factor shares. Once you start putting different factor shares, I mean, one concern is that there's going to be a positive correlation, no, between how capital intensive the technology is and how advanced that technology is. So you can think that you are moving to use a different technology that uses more capital and less labor.
So the factor shares are changing in our exercise.
Exactly.
As they do in the data. So
yes.
This is going into the estimation. We don't impose that they're fixed.
I know,
okay.
But that's exactly, so when, I'm going back to thinking about, the paper by Andres Rodriguez-Clare and Pete Clino, complaining about the neoclassical revival in growth economics. No? And here, that was exactly, one of the points is, you need to calibrate these factor shares and keep them constant so that you will only use this variation in quantities to back out the A's. And there they found that these A residuals were explaining a lot of the variation. Here, because you are plugging in these varying factor shares, I don't know to what extent, the exercise of recovering these solo residuals makes sense in the sense that these factor shares are going to be positively correlated with technology. You're trying to separate, I mean the whole exercise, let me put it this way, the whole exercise of trying to separate A from K, no, technology from capital, somehow holds technology constant by holding this factor share constant. I mean, traditionally, this is, so here you're doing something different by using these varying factor shares, and I'm not sure how to think about these.
Yeah, I think you should think about it as solo data. So it's no matter, yes, you can have capital augmenting technical change. Whatever we do in this exercise here is we back it out in terms of Higgs neutron units. So it's a TFP. Yes, you're right. I mean, you could have factor-specific technical change, but you kind of back it out and express it in terms of Higgs neutron units. That's kind of what we do here. No matter what in Solov's exercise, no matter what the nature of technical progress is, it can be factor augmenting or not factor augmenting. You just back it out here and express it in terms of Higgs neutron units. That's all we do.
But to the extent that these changes in A are correlated with changes in the alphas, I am not sure how you can separate these two things. This is, a technology that is more capital intensive is also going to be more advanced. So to what extent you can separate? Of
course, it relies on an assumption that there is a global neoclassical production function.
Yes.
Yes, absolutely. That's an underlying assumption.
Yeah.
Good. We are more worried about when you then specify the production function, you're assuming a fixed neutrality, then it's going to
No, that's right. That's good.
You're saying, post-primary elasticity factor around 1 because it's here factor.
I'm not worried about this here because I just back it out, but in the next step I am. Yes, that's right. Absolutely. I agree with that.
Yes, doesn't matter where the technology is.
Again, I just say I fit something, and this is what these data suggests.
So you're assuming Higgs neutral A's, right? That there's not factor bias.
Absolutely. In the next exercise, here I just back it out and express it in Higgs Newton units. In the next exercise, I assume that's right. It's an additional assumption. Good. And I impose a function formula. Okay, I should speed up a little bit. 10 minutes left. So, yeah, let me be fast on the next one, which is the preference structure. So you need to you can estimate preferences. Preference need to be non-homothetic to be able to speak to this question and to be in line with Engel's law, basically. So what we do is we use this kind of specification, which is a simple one. Is non-homothetic. It's your constant expenditure elasticity of demands, which you can estimate either from the cross-section or what we do here is actually we go to the US time series and estimate. So this is kind of the one key parameter that we estimate in the US time series, which is the expenditure elasticity of demand for food is 55%. So if you increase your income by 10%, increase food expenditure by 5.5%. Yeah. And the other parameter that is controlling basically the elasticity of substitution, we also back up from the US time series. If you do that and plug it into the cross-country data, you see it's quite a powerful mechanism to give rise to differences in the demand structure. If you would lower the expenditure elasticity of demand for food even further, you would get all the way up. The other thing that is nice about this structure is that the function form seems to fit the data well because it's very isoelastically declining. Whereas if you would use those subsistence level of consumption, what you tend to get is initially a very steep drop and then it levels out quite rapidly. So let's then just put the things together, and we of course have a theory, and it is going to be a dynamic general equilibrium model where we also take into account capital accumulation. So we think about the standard household problem subject to a standard budget constraint giving rise to standard Euler equation. We also put in, just to have them in place, some wedges, but they are not relevant for today. Firm problem is standard, perfect competition. There is just a representative firm in each sector active. And what you get out of this is then we compute a steady state. Okay, so we assume that each country is characterized by a particular level of development, which is particular AX, AA, AN, and AK. And then we just calculate the steady state level of capital stock in this economy. And then we put the pieces together, and basically the calibration is very brief because I already estimated these elements that are going to put in step by step. So we have TFPs, as I already showed you, preferences, as I already specified and estimated in the US time series. And then we're going to use this particular nest, as I showed you initially. And for the non-agricultural sector, we do the similar exercise and conclude the cryptography is doing a good job at describing the data. And then basically you can look at how it performs in terms of aggregates, and it does quite nicely in terms of nominal capital output ratios, as in the Penwell table, or the aggregate labor income share, which is non-trivial because I was a bit concerned. You have the structural change, you have different labor shares. How does it play out in the aggregate? But it does fit the data quite well. And yeah, the last thing I wanted to show you are now counterfactuals. And we are particularly interested in two counterfactuals here. One is, suppose you improve agricultural TFP. You take a poor country like Burkina Faso, increase TFP in agriculture to the level of the US. What happens? Does this country become rich? Halton's logic would suggest initially, yes, you get a big kick out of it, but this effect peters out quite rapidly. The second exercise we do is suppose you increase non-agriculture TFP in Burkina Faso to the US level. What happens then? In particular, big question is how does this economy solve the food problem? Because they are stuck with their low TFP in agriculture. And here is kind of the effect that we get. Okay, so let me go slowly. So here we take a poor country like that, and then we show what happens in terms of aggregate GDP per capita or per worker in this country if you increase. Here the red one is agriculture TFP to the level of the US, here, and non-agriculture TFP to the US level. So if you would close all the income gap, you would get the 45-degree line. And here we just vary across the different levels of development. And what you see is that, yes, initially this is relatively steep, but it peters out very rapidly. So basically, if you go to Burkina Faso, increase TFP in agriculture to the level of the US, you escape poverty, but you cannot even become a middle income. The shape is also interesting. So it really peters out because you have these structural change forces. You become more productive in agriculture, but this leads to a structural change out of agriculture. So the initial big effect decreases, the effect that you get out of increase.
Excuse me, Timo. So what's special about this exercise? It means if I take a standard two-sector model and apply to your cross-country data, and I do this exercise, what do I get?
I mean, that's sort of what you're doing. Or what do you mean by
standard? But so I mean, is the non-Cobb-Douglas form of the production factor in agriculture telling me something quantitatively relevant
absolutely.
here?
Yes, absolutely. That's important. Yeah.
Yes.
I mean, maybe the easiest is to explain it with the green line, because here you kind of get the opposite shape. So here you get more and more boost out of an increase in non-agriculture TFP. And that has two reasons. First of all, there's structural change out of agriculture. So that means that the weight that this sector gets the boost is increasing. And the other thing is, yes, by increasing TFP in non-agriculture, you also become better at producing fertilizer and capital goods. And this leads to capital deepening and intermediate input intensification in the agriculture sector and increases labor productivity in agriculture. Yeah.
So you told me before that, I mean, for all practical purposes, we can think about tractors and fertilizer, same dollar price around the world, right? So if I think about this country now, it has same productivity as the US in agriculture. So why prevents it from buying these things at the same cost of the US and export the agricultural output that it gets, and then it becomes the US? No?
Yep. Yeah, I mean.
So in that exercise with trade, you go all the way to the 45-degree line.
No, okay. That was a surprise to me. I thought this initially too. The reason, I mean, you're right, specialization and free trade would allow you to just jump on wherever you have a comparative advantage, and that's kind of the logic. This is definitely true for non-agriculture. However, for agriculture, you have still land as a limiting factor. So you cannot fully specialize because you run into decreasing returns. So even though you have a high TFP, you cannot leverage it to the same extent as for manufacturing. They just can shift all the production factors into manufacturing and export.
Because the country doesn't have enough land, that's the issue.
Exactly, you run into decreasing returns because of the land. That's kind of the. So of course, qualitatively still go in this direction. That's right, but you cannot leverage it to the same extent.
Seems like a good benchmark. I mean,
yeah. Okay. Yeah. No, absolutely, I agree. But I was also pleasantly surprised by that comes out of our model, that you have land as a fixed factor, and that prevents you from fully leveraging a comparative advantage in agriculture. Okay, I think I should wrap up. So yeah, here we split it up between different exercises, but basically the main message comes out of it. Yeah, let's not talk about this, but this is another potential application why we care about this. I think for predicting what happens when climate change or demographic changes the amount of fertile land per capita, we sort of need this type of framework, at least a quantitative framework of this style. It's a big contrast if you go to the IPCC. They have actually a similar framework, a computational GE model, but then if you look on the underlying assumption, they use Leontief between value added and the intermediate inputs, very different from us. And the elasticity of substitution of primary factors like capital and land are put to equal to 0.26. So you get very different predictions out of such a framework. So I think that's one motivation that we should get it right in the end, collectively. So just to summarize, I put the pictures again because I'm out of time. But yeah, I guess I stop there. Thank you.
Okay, we have a question for one or maximum two questions. Okay, so it's 4 o'clock. We can close the session and thank you.